Welcome to another inorganic chemistry lesson. In this lesson, we'll talk how to use oxidation reduction to balance different reactions. I divided this lesson into two parts. In the first one, we will be talking about oxidation reduction, and in the second part, how to balance chemical equations using this method. So when can we use this method? Well, the only rule for this method is that two elements must change their oxidation state in the chemical reaction. Before we dive into solving reactions, we must learn how to write have reactions, which compounds or ions are oxidized and which are reduced. Let's say we have a reaction where aluminum reacts with sulfur and produces aluminum sulfide. The first step of oxidation reduction is to determine what oxidation states are present in this reaction. The pure element oxidation state is always zero. So aluminum and sulfur are 0. Now in aluminum sulfide we have ions. For aluminum, its charge is 3 plus, and sulfide's charge is 2 minus. The next step is to write have reactions. In oxidation reduction reactions, electrons are transferred from one compound to another, and that is what we show in the have reactions. Because aluminum gained or lost electrons, it became aluminum 3 plus cation, and pure sulfur became sulfide anion, and that's what we write in a have reactions. Let's remember what 3 plus and 2 minus means. A positive oxidation state always shows that electrons were lost during the reaction, and a negative oxidation state always shows that electrons were gained during the reaction. So aluminum lost 3 electrons and became an aluminum ion. Now we can write minus 3 electrons before the have reaction, or we can write plus 3 electrons after the reaction. Like in mathematics, when you place a number from one side to another, sign changes. The same goes for sulfur, but in its case, sulfur gained 2 electrons and became a sulfide anion. Now, whenever electrons are lost, we say that compound was oxidized. And whenever electrons are gained, we say that compound was reduced. Simple way to remember this includes the mnemonic device oil rig, meaning oxidation is loss and reduction is gain. Also, the two species that exchange electrons in the redox reaction are given special names. The ion or molecule that accepts electrons is called the oxidizing agent. By accepting electrons, it oxidizes other species. And the ion or molecule that donates electrons is called the reducing agent. By giving electrons, it reduces the other species. Now, is there an easy way to remember when the compound is oxidized or reduced? Well, imagine I have a straight line with different oxidation states on it. On the right side, I have positive oxidation states. In the middle, neutral oxidation state 0. And on the left side, I have negative oxidation states. If we are going from the left side to the right, then the compound or ion is always reduced because it gains electrons. And if we are going from the right side to the left side, the compound or ion is always oxidized because it loses electrons. Let's look at more examples. In this case, magnesium reacts with hydrogen chloride and produces magnesium chloride salt and hydrogen gas. Once again, we must determine which oxidation states are present in this reaction. Because magnesium is a pure element, its oxidation state is 0. Hydrogen charge is plus and chloride is minus. In magnesium chloride, magnesium is 2 plus, and the chloride charge hasn't changed and is still -1. Lastly, hydrogen is a pure element, so its charge is 0. If you have a hard time understanding the element's oxidation state, I recommend you to watch my second and third lessons. Now let us get back to this example. We can see that only magnesium and hydrogen changed their oxidation state, and chlorine stayed the same throughout the reaction. Let's write have reactions. For magnesium, pure magnesium became 2 plus cation, and for hydrogen, hydrogen cation became a pure element. Remember that when a pure element becomes a cation, it always loses electrons. So in this case, magnesium lost 2 electrons and was oxidized. Hydrogen cation, on the other hand, gained 1 electron and was reduced. There must always be one compound or ion which is oxidized and one which is reduced. Now, because magnesium was oxidized, we say that a pure magnesium is a reducing agent. And because hydrogen accepted electrons, we call it oxidizing agent. It is very easy to remember. Reduced compounds always be an oxidizing agent, and oxidized compounds always be a reducing agent. Okay, what if we have a reaction where iron-free oxide reacts with a hydrogen gas? In this reaction, a pure iron and water are produced. Let's look at the charges. For iron, it's 3 plus, and oxide is always 2 minus. Because hydrogen and iron are pure elements, their charge is 0. And in water, hydrogen is plus and oxygen is 2 minus. Now how about the have reactions? Iron cation became a pure element, so it must have gained 3 electrons in that process. And because of that, we say that iron was reduced. A pure hydrogen lost an electron and was oxidized. Lastly, we write that iron was oxidizing agent and hydrogen was a reducing agent. And now we have correctly written both have reactions. In today's last example, sodium reacts with water, where sodium hydroxide and hydrogen gas are produced. Sodium charge is 0, hydrogen is plus, and oxygen is 2 minus before the reaction. After the reaction, sodium is plus, oxygen is 2 minus, hydrogen in a hydroxide ion is plus, and pure hydrogen is 0. We can clearly see that sodium was oxidized and lost an electron, and hydrogen was reduced and gained an electron. It doesn't matter that there are 3 hydrogens in the reaction. We only searching for particles that change their oxidation state. Sodium in this reaction is a reducing agent, and hydrogen is an oxidizing agent. And that's all for today's lesson. Like always, I will leave a few exercises for you. Please subscribe to this channel for more chemistry content, and see you in the next lesson.